Exception handling in Python. Previously, we talked of some built-in exceptions in Python. Now, let's learn to handle them using try except blocks and the finally block, intentionally raise exceptions, talk about assertions, and define our own exceptions. You know we get a zero division error when we try to divide by zero. This is a problem as exceptions only show up at runtime and can break your code. Nobody likes malfunctioning software. Can we somehow find a way to fix this? Well, we can use try except blocks. If a statement is probable to raise an exception, put it in a try block. In this for loop, we print the division of 3 by numbers 0 to 2. So we've put this in a try block. This statement doesn't print because whenever it encounters an exception, it skips to the next statements and looks for a way to handle this exception. An except block follows this. This is where we put the code that will handle this exception. We make it print u divided by 0. This prints because the exception was handled. In this example, we did not specify which exception to handle, but it encountered a zero division error, so it handled that. For a try block, we can specify multiple exceptions to handle and how to handle them. For this purpose, we may have multiple except blocks. A is 1 and B is 0. There are two exceptions here, one for the division and one for adding a string to an integer. This except checks for a type error and this one checks for a zero division error. But in the output, we can see that it handled the zero division error because even though the except for it is before the except for the zero division error, it first encounters dividing by 0 and so raises this exception first. So while exceptions do break your code, if you successfully handle an exception, anything after it is handled will be executed. Here, we handled whatever exception this raised. This was a zero division error. The print statement for will this print is outside the try except blocks, but it does make its way to the output. We used multiple except blocks, but we can also put multiple exceptions in one except block. This one checks for a type error and also for a zero division error. For both errors, it handles them by printing out the words invalid output. And if you check for multiple exceptions and still want to make sure everything is properly handled, you can put a generic except block after it all. If an exception raises and none of the specific excepts can catch it, the generic except will catch it and handle it. In this code, the first exception raises when adding an integer to a string. Is this a name error? No. A zero division error? No. So now, this except will handle it. You cannot tear a try-catch pair apart by stuffing something between the two, like a print statement. It raises a syntax error. But can you have multiple generic excepts? Also no. This is a syntax error too, and it says the default except block must be placed last, after everything else. What was that finally block in the last example? Well, this one goes after the last except block. Whatever you put in this executes whether there has been an exception or not. This, again, raises a zero division error. In the output, you'll notice that it prints this line in the finally block and then raises a zero division error. Now you know how to handle exceptions. But what happens if another exception occurs when handling an exception? I mean, it's only code you put under the except block. It is definitely possible for this code to raise an exception. This code raises a zero division error while handling another. The code under finally does execute and it prints out two tracebacks and informs us that when handling one exception, another was raised. Sometimes we can choose to raise an exception. Let's take input to variables a and b. The user inputs the values 1 and 0. If b is 0, do raise a 0 division error. So this raises it. In this one, we put this in try, and then to handle the exception we just raised, we provide an except block. Run it and enter inputs, and you'll see that we've successfully raised and handled an exception. But in this example, we knew what exception to raise. But for the times we don't know what exception is raised, we can also re-raise it in the except block. This raises a type error. So this goes to show that it is possible to use the raise keyword in itself. Yet another way to use this keyword is to give it an argument about what to print along with which exception to raise. This statement raises a value error, and for the details it prints inappropriate value. Let's talk about assertions once again. They are like sanity checks for the programmer. They are ways to ensure that everything is going as expected. An assertion checks the truth value of an argument and raises an exception if it is false, but performs a no operation otherwise. True is, well, true, so this does nothing. But 1 is not equal to 0, so this raises an assertion error. We have two assert statements in this code. This is the output. This is okay. This is true. This is okay, but this is false. So this is where it raises an assertion error, and it doesn't print this. It handles this exception by printing an assert just failed, and then re-raises the exception that occurred. And finally, it prints OK. By isn't printed because we re-raised the exception when handling it, so the program is now halted. If we hadn't re-raised it, there would be no traceback and it would print by as well. Like the raise keyword, we can provide a second argument to assert. This is a way to provide extra information to the user through the assert statement. This assert has a condition that's always false because it is literally false. And this raises an assertion error saying, Houston, we have a problem. Let's also learn to define our own exceptions. We can do this using classes. Let's derive a class from the exception class. This is class myError, and it derives from class exception. Let's raise an exception of this kind, an object of this kind, while also declaring what to print next to it. Successful. In this module, so far you've learned about exceptions, how to handle them, and how to create your own. Next, let's learn to perform unit testing with the unit test module.